Hi class. This video is going to look at 4 things: strings versus chars, how to give names to the identifiers we're going to use in our program, how you can improve the readability of your source code, and since everything is zeros and ones in RAMs, we're going to introduce the concept of data types. Terms you should know are string literals, and what's the difference between a string and a char. So a string is just a sequence of characters. You had a string last week, a string literal last week with hello world. And you know when you output hello world, you have that inside of quotes, but the quotes does not output. The quotes are what makes it a string literal. So there's another way that you can have a string in your program, and that would be a string variable. So a variable, just like in algebra, you had x and y, and those held a number. You can have a variable that is just a placeholder for the actual string. So if you ask someone to input their name, and they input Bob, you need to store that in a variable. And that variable is a string variable. So you have a string literal in which you know exactly what you want to output in a program. You put quotes in there. But sometimes you want to output what somebody had input. You don't know what they're going to input. So you store that string input into a variable. Here are some examples of what are not string literals. What you cannot do is put it on 2 lines. Just use your print line, right? You know that the print line statement will bring it down to the next line, but don't bring the actual string literal down to the next line. Here's another thing. We've got quotes within quotes, and that's not going to be permitted. What's going to happen is Java's going to say, okay, this is one string, and here's the beginning. Here's another string. What's this legal in between? That doesn't make sense. So it sees 2 separate strings with some odd stuff in between. It's going to give you an error. Let's look at char. Now, you may hear it pronounced care. It's short for caring character, but programmers pronounce it char. And Java is going to treat a single character, a char, separately from a string. So a char is going to have only one character. It's actually represented with the Unicode characters, and a char literal will have a single quote and not a double quote around it. So look at this example here. There's a problem here. We've got single quotes, but if it's a char, it needs to be exactly one character, and this is way more than one character. One thing you're allowed to have, however, the opposite you can do. You can have one character, such as the letter A, and say, no, that's going to be the string A. Java's going to say, oh, it's the string versus char, and it stores it differently in RAM. That comes next semester. Let's talk about naming things. So an identifier is just the name you decide to give an entity in your program. So an entity could be your class, or a method, or it could be a variable. And we'll be talking more about variables soon. As the coder, you get to make those names up. So, but there are rules, and if you break the rules, your program won't run. So here are the rules. It must start with a letter, and then you can have, A through Z. It could be uppercase or lowercase, but more on that in a minute. And then you can have numbers or digits. You're also allowed to have a $sign and an underscore. But notice you can't have a dash, you can't have a backslash. So most of the non-alphanumeric characters you cannot have, with the exception of the $sign and the underscore. Other characters, spaces aren't allowed. Java has some predefined keywords, and you'll find that in Appendix A. And so you cannot call a variable name using one of those predefined keywords. So here are some of the Java keywords. So you could not create a variable called abstract or catch or do. Okay, just remember it's not a very long list. No variables can have these names. So those are the rules, and if you don't follow those rules, then the program won't compile. But there's also some conventions, and this is to help with readability, which we're going to get to in a second. And these conventions are guidelines. If you don't follow the guidelines, it's still going to run. So one guideline is for classes. Your class name The guideline is started with a capital letter. And your method names, the guideline is started with a lowercase letter. Same with variables, lowercase letters to start variable names. But when you start to put words together, so I wanted to do hello world, what you're going to see that you're doing is start with a capital letter for a class. Everything else is lowercase until we get to a second word. Remember, you can't have spaces in identifiers. So this helps us to see that this is two words. Since the class begins with a capital letter, we're going to do hello world for class. Let's look at this one, a method. Now a method begins with the lowercase, but there's three words. So we have calculate, lowercase. Now we come to the second word, capital S for sales. Third word, capital T for tax. Now you might hear this called Pascal casing or camel casing. I like camel casing because think, there's a hump in the middle. So camel casing is a good term for that. A variable name begins with a lowercase, user, and then there's the next word, name. Another thing about Java is it is case sensitive. So if I create a method called calculate sales tax, and then I do calculate sales tax with a capital C here, Java's going to say they are not the same. Each of these are allowed and they're all considered different things. Readability is important because you might find you're coming to read your source code to make a change after 6 months and you're wondering, what did I do here? Or it is very common when you first get a job that you might not be writing your code from scratch. You might be given the job of modifying someone else's source code. So heaven forbid, you want to be able to read other people's source code and you want to make your source code readable. How do you do that? First of all, let's make your identifiers reasonable. So if I had a variable called X, what does that mean? What is X storing? Here's some examples. In this case, I want a variable and it's going to store the temperature needed for the oven when baking cookies. I could call it T. First of all, what does T mean? Does it mean tax? Does it mean tip? Maybe it means temperature. Also notice this uppercase, which we don't want to do for a variable name. Temp, T-E-M-P. Well, that's a little bit better than T. But what does it mean? Does it mean temporary? Does it mean room temperature, current oven temperature, or temperature needed for baking the cookies? Because when you first turn the oven on, the current temperature is increasing until it gets to your setting. How about the oven temp? Getting better. Okay, not using camel casing. You want to do oven temp instead. Does it mean the current oven temperature or the temperature needed to bake? Here, oven temperature for baking. No, uses the camel casing, very readable. It seems like I wouldn't want to have to type that in a lot of times. It's a lot of characters. But as you get into using IDEs, you will find there's all kinds of shortcuts to bringing your variable names up. So you start typing a couple letters, you find that matches and go for it. So you really do not have to type your variable names all the way in every time. So long is okay. It's not going to take too much time. Current oven temperature, totally know what that means. Again, using camel casing. Another thing that's going to make your code more readable is comments. So when you go in and read somebody else's source code, those comments are really going to help you. There's line comments, block, or also called multi-line comments that might go, of course, many lines. And there's java.comments. You're going to have a little discussion posting on java.comments. So your line comments will begin with 2 slashes. And it can be the entire line, or it can go after some code. So here I've got a squiggly brace. This bracketing the end of my method. Well, actually, it's the end of my class based on my comment. I know. And I could have been confused. Maybe it was the end of the method, but now I know because of the comment, it's the end of the class. You're going to see there's squiggly braces all over the place. Then there's block or multi-line comment. What you're going to do is the beginning of your comment, you're going to have slash star or asterisk, and at the end, you say, okay, that's the end of my comment block, star asterisk. So here I have an example. And then finally, java.comments can be compiled into HTML, and it can help you write like help files that can go up on a website. So here is an example of a java.comment. In addition, java.comments also have parameters. And these parameters will begin with the @ sign and have a special keyword. Well, I just started a NetBeans program, and it automatically added some Java doc comments for me. But then I formatted a little bit more. Okay, and here it is. Here is the beginning of my package in NetBeans, the beginning of my class. In between, you will see some Java doc. Notice it starts with the / and 2 stars, and this one doesn't. So that's just a regular comment. And here is the @param. There's the @author, the @version. Another thing that can improve readability is to add some white space. For example, each statement, go ahead and put them on a separate line. And indent properly, very important for readability. You notice I have my opening class, and this is, I don't have a comment after it, but this is the ending of my class. That's the braces, right? And you notice everything inside of it is indented. So that's an important part of readability. Again, here is my closing brace for my main, and everything inside of that is indented. Don't do this. Here I have the class name followed immediately by the method name, followed by one statement following another statement. Very not readable. Okay, finally, let's talk about what a data type is. The data that you're storing has a data type. And why does it have a data type? That data type tells the program what type of operations can be performed on that data. Let's say you have some string data. Should you be able to multiply that data? No, I've never multiplied Debbie times Florida. Okay, so no, you should not be able to do that. But let's say I have some numeric data. Obviously, the multiplication operation should work. Should be able to do that on numeric data. So we have a little bit of RAM, and let's say this is what's stored in RAM. Here's the zeros and ones. Did you know it could mean a lot of things? So we need to tell the program, what do those zeros and ones mean? Thank goodness we don't have to input the zeros and ones ourselves. Okay, the computer takes care of taking in the characters we enter and converting it into Unicode or into binary data. If this were a string, this would be the string lowercase a. If this were a char data type, this would be a lowercase a, of course, in single quotes. This is actually 66. I don't know if you ever done binary conversion, but that is not 66. Or the integer 65. I don't know if you remember doing binary conversions, but that's 64 plus 1, 65. Or it could be that floating number, or it could be a machine code instructions, so on and so on and so on. So we have to define in our program while we're writing our source code, the data that we're going to get in here is going to be a string. And we'll get to that next week. All right, now I have a quiz for you over these concepts that we just covered. Good luck.